Hello friends, in this video we are going to discuss paper 2 of JEE Advanced 2014 chemistry section. Okay, so let's see the first question. The first question says the acidic hydrolysis of ether X shown below is fastest when one phenyl group is replaced by a methyl group, one phenyl group is replaced by a para-methoxyphenyl group, two phenyl groups are replaced by two para-methoxyphenyl groups, no structural change is made to X. Well, the correct option here is option C. And the reason is that when two phenyl groups are replaced by two para-methoxy group, carbocation form will be more stable. That when two phenyl groups are replaced by two para-methoxyphenyl groups, the carbocation formed is more stable. Okay, so remember this, that in this case, in the case of 3, the carbocation which is formed is more stable. Okay, so now let's see another question. The question states that isomers of hexane based on their branching can be divided into 3 distinct classes as shown in figure. Yeah, okay, so this is the given figure. So the correct order of their boiling point is, here in this case, since more the branching in an alkane, lesser will be the surface area and hence lesser will be the boiling point. Since more branching gives lesser surface area and hence lesser boiling point. Okay, so here in this case the boiling point of 3 will be the greatest, followed by the boiling point of 2 and then the boiling point of 1. So the correct option is B. Okay, so now let's see another question. Question states the major product in the following reaction is, the reaction is given to you, the major product they have asked. Okay, so here the reaction sequence is something like this. Here we have this, we have got this as reactant. When reacted with CH3 after step 1, CH3 MgBr 0 degree Celsius in dry ether, we get the product like this. Okay, and now when it is treated with aqueous acid, then this oxygen reacts here, this gets eliminated, and the product that we get is something like this. Okay, here. So the correct option here in this case is option A is incorrect, B is incorrect, C is incorrect. Correct option is option D. Okay. So now let's see another question. The question states that hydrogen peroxide in its reaction with KiO4 and NH2OH respectively is acting as, well, let's see the reactions of H2O2 with KiO4 and NH2OH. With KiO4, the reaction is like this. It gives KiO3 plus H2O plus O2. And with NH2OH, the reaction looks something like this. So if you balance it, the coefficient of H2O is 4 and that of H2O2 is 3. So here in this first case, the hydrogen peroxide is acting as a reducing agent. In this case, the hydrogen peroxide is acting as a reducing agent, and therefore either of option A or option B is correct. So now in second case, the H2O2 is acting as an oxidizing agent. So option A is the correct option. Here the oxidation state of iodide is +7, and here it is +5. So here clearly you can see that it is acting as a reducing agent, and in the same way here it is acting as an oxidizing agent, because here the oxidation state of nitrogen is -1, but here the oxidation state of nitrogen is +5. Okay, so so now let's move on to another question. The product formed in the reaction of SOCl2 with white phosphorus is, so with white phosphorus the reaction of H2SO4 is like this. Okay, so here the correct option, as is evident by the reaction, the correct option is option A, that is PCl3. Okay, so the next question, let's move on to the next question. Question is, under ambient conditions, the total number of gases released as products in the final step of the reaction scheme shown below is. This is the reaction scheme given to us. And then okay, so if we draw the particular reaction here, the reaction will look something like this: XeF6 plus 3H2O gives XeO3 plus 3H2F2. Now further it undergoes reaction with OH negative and it gives HXeO4 negative. Okay, now it undergoes disproportionation here in this condition, and the products formed is XeO6 4 negative plus Xe plus H2O liquid plus O2. Okay, so so here we can see that the number of gases which are released is 2. The first is this one and the another is this one. Okay, so the correct option is option C. Okay, so now let's moving on to another question. For the identification of beta-naphthol using dye test, it is necessary to use dichloromethane solution of beta-naphthol, acidic solution of beta-naphthol, neutral solution of beta-naphthol, alkaline solution of beta-naphthol. Okay, the condition for this particular reaction is here. And in dye test, it undergoes reaction like this. Under alkaline solution. Under alkaline solution, this is the identification test of beta-naphthol. Okay, so the correct option here is D, the alkaline solution of beta-naphthol, in order to keep the equilibrium in forward direction. So now let's move on to another question. Question here states, for the elementary reaction M2N, the rate of disappearance of M increases by a factor of 8 upon doubling the concentration of M. The order of the reaction with respect to M is, well, here if we write the rate in first condition as R1 and the rate in second condition is R2, then we'll write here R1 upon R2 equals 1 upon 8. Now since we have increased the concentration by the factor of 2, here the power n, so this will give us n equals 3. So the correct option is B. The order of reaction with respect to M is 3. Okay. So now the question here says, for the process H2O liquid to H2O gaseous at T equals to 100 degrees Celsius and 1 atmospheric pressure, the correct choice is, well, at T equals to 100 degrees Celsius and 1 atm, at T equals 100 degrees Celsius and P equals 1 atm, because this reaction H2O liquid to H2O gases is at equilibrium. Okay, and hence therefore delta S of total is 0. And since we can see clearly with the given reaction that delta S of system is greater than 0, because degree of randomness is increasing in when the system goes from liquid state to gaseous state, and therefore since delta S total equals to 0, and we know that delta S total equals delta S system plus delta S surrounding, okay, equals to 0. Since delta S system is, therefore delta S system is greater than 0, since here it is given that reaction that the system goes to gaseous state from liquid state, therefore this implies that delta S of surrounding is smaller than 0. Okay, so here the correct option is option B. Okay, so now the next question. Assuming 2s2p mixing is not operative, the paramagnetic species among the following is, well, Be2, B2, C2 and N2. So let's write the molecular orbital diagram here. So here Be2, it has the arrangement like this: sigma 1s2, sigma star 1s2, sigma 2s2 and sigma star 2s2. This is diamagnetic. Okay, since here no unpaired electrons are involved. In case of B2, the arrangement is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, and now here pi 2px0 and pi 2py0. Okay, so because since the 10 electrons are completely over, and hence this is also diamagnetic. Okay, now for C2, the arrangement is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and sigma star 2s2 and sigma 2pz squared. Here now since pi 2px1, since they are of equal energy, and this will be pi 2py1. Okay, so this is paramagnetic. This is paramagnetic. Therefore option C is correct. And now to confirm, the arrangement for N2 is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2 sigma 2pz squared pi star sigma 2pz squared okay. So now this will be pi to 2px 2 and pi 2py 2. These two will be equal in energies, almost equal in energy. So therefore option D is also incorrect. So the correct option is option C. Okay. So now let's move on to another question. Okay, so the question is a comprehension type question. So schemes 1 and 2 describe sequential transformation of alkynes M and N. Consider only the major products formed in each step for both the schemes. Okay, so we are considering the major products, and the sequence is given like this. The product X is and the product. So now we need to determine the product X and product Y. Let's write the reaction scheme here in this case. So the reaction scheme is H. Now with NaNH2 it will undergo reaction like this. Okay. So now if treated with CH3CH2I, it will be okay. Now after treating with CH3I, the product will look something like this. Okay, now when H2 with Lindlar's catalyst is treated, then the product is H3CO H this. So this is our X here. Okay, so the correct option here in this case is option A. Okay, so the correct option here in this case is option A. Okay, so now let's move on to determining the product Y. Okay, so the reaction will undergo like this. The reaction scheme is H, Na and H2, and now only one equivalent is there, therefore this will be the product. And now after treating with BrOH this and NaNH2, again one equivalent, okay. So this will be and now after treating with H3O positive, that is mild conditions, then the product will be like this. Now with reduction with the hydrogen palladium charcoal, this will be okay. Now after oxidation with CrO3, the final product is this alcohol will get converted into ketone, will get oxidized to ketone. So now on observation of Y, this is our Y. Well, okay, so here this is our Y in this case. So on observation on observation of or on comparing X with Y, we can see that X and Y respectively, they are the functional isomers of each other, and here Y in this case, it gives the iodoform test. Okay, so the correct option in this case is option. It gives the positive iodoform test and is a functional isomer of X. So the correct option is option C. Okay, so now let's move on to another question. Move on to the next question. An aqueous solution of metal ion M1 reacts separately with reagents Q and R in excess to give tetrahedral and square planar complexes respectively. An aqueous solution of another metal ion M2 always forms tetrahedral complexes with these reagents. Aqueous solution of M2 on reaction with reagent S gives white precipitate which dissolves in excess of S. The reactions are summarized in the scheme given below. So this is the scheme given to us. Okay, so this is the scheme given to us, and the question is asking that M1, Q and R respectively are. Okay, so here in this case, so if this reaction scheme is more suitable for nickel here, nickel complex, so let's see what happens in case of nickel. So Ni2 positive here with KCN gives NiCN whole 4 to negative, and this is square planar. This is a square planar complex with where KCN is axis. Now this same nickel 2 plus when reacted with HCl in excess it gives NiCl4 2 negative, and this is tetrahedral. Okay, now since KCN is a strong field ligand, therefore it will not give us the tetrahedral complex in this case. So therefore KCN will give the square planar complex, and nickel option B is the correct option. Okay, so here now if the another question is the reagent S is. Okay, so here let's take the case of zinc first. Okay, so taking the case of zinc with HCl, it will give us the tetrahedral complex 11Cl4 to negative, and with KCN it gives again the tetrahedral complex. Okay, so in these two conditions it gives us the tetrahedral complex, but while treating with KOH it gives us the white precipitate. Now again, if we add KOH in extra, then it will get solubilized due to the formation of this complex, which is soluble. Okay, so here the correct option is option D. Okay, so now let's move on to another question. X and Y are two volatile liquids with molar weights of 10 gram per mole and 40 gram per mole respectively. Two cotton plugs, one soaked in X and the other soaked in Y, are simultaneously placed at the ends of a tube of length L equals 24 cm as shown in the figure. The figure is given to be like this. Okay, so the tube is filled with an inert gas at 1 atmospheric pressure and at a temperature of 300 Kelvin. Vapors of X and Y react to form product which is first observed at a distance d cm from the plug soaked in Y. Take X and Y to have equal molecular diameters and assume ideal behavior for the inert gas and the two vapors here. Okay. The value of d in centimeter as estimated from Graham's law is, okay, so according to, if we apply here Graham's law, then Rx and Ry will be equal to D upon 24 minus D equal to under root 40 upon 10. You know that R1 upon R2 equals under root M2 upon M1. So here in this case, since molecular weight of Y is 40 gram per mole and that of X is 10 gram per mole, therefore we'll use here under root My upon Mx. So this will be equal to 2. So from here we can say that D equals 48 minus 2D, which gives us D equals 16. Okay, 16 centimeter. So the correct option is option C. Okay. So now the experimental value of D is found to be smaller than estimate obtained using Gram's law. This is due to larger mean free path of X as compared to that of Y. Larger mean free path of Y as compared to that of X, increased collision frequency of Y with the inert gas as compared to that of X with the inert gas, increased collision frequency of X with the inert gas as compared to that of Y with the inert gas. Well, as the collision frequency increases, then the molecular speed decreases than the expected. Okay, so here, as collision frequency increases, molecular speed decreases than the expected. Okay, so the correct option here is the option D. Okay, so now we're moving on to another question. The question is matching list type questions. Okay, now different possible thermal decomposition pathways for peroxyesters are shown below. Match each pathway from list 1 with an appropriate structure from list 2 and select the correct answer using the code given below the list. Okay, so here this is the given reactant to us. Now these are the different conditions and these are the products. Okay, so now let's see what is happening here in this case. What is happening actually here in this case? So in case of P, what's happening is that in case of P, we are reacting it here with minus CO2. Okay, so in case of P, it is happening like the actually thing that which is happening is H5C6H2 OCH3. Okay, so the radicals which are there are C6H5CH2 plus CO2 plus CH3O dot. In case of Q, it is H5C6H2 CO CH3 CH3 CH2 C6H5, and the radicals are C6H5 CH2 dot plus CO2 plus CH CO2 CH2 CO dot CH3 CH3, which further decomposes as PHCH2 dot plus CH3 CO CH3. Okay, so and in case of R here, this is happening is C6H5 CH3 CH3 C6H5, and the radicals obtained are C6H5 CO2 dot plus CH3 CO dot CH3 C6H5, which further decomposes as after the elimination of carbon dioxide as PH dot plus CH3 CO PH plus CH3 dot. Okay. So now the final case, in case of S, the sequence is C6H5 CH3 gives C6H5 CO2 dot plus CH3O dot, and now this undergoes decomposition as C6H5 dot. This undergoes decomposition as C5H5 actually. C5H5 dot plus CO2. Okay. Oh, this undergoes decomposition as C6. I have written it wrong. It is C6H5 dot plus CO2. Okay. So now let's move on to another question. Well, here in this case, the correct option is this corresponds here. P corresponds to 1, Q corresponds to 3, Q here, it corresponds to 3, and R corresponds to here, it corresponds to 4, and S corresponds to 2. Okay, so the correct option here is option A. Okay, now so let's see the other question. Question says, match the 4 starting materials PQRS given in list 1 with the corresponding reaction schemes provided in list 2 and select the correct answer using the code given below the list. Okay, so here we are given with some starting materials, and after different schemes, it undergoes it gives us certain products. So let's see what are the reaction schemes here in this case. Okay, so in case of P, the reaction goes something like this: P, H, H. Now in red hot iron at 873 Kelvin, iron at 873 Kelvin, it gives us benzene. Now if treated with fuming HNO3, H2SO4 and heated, it gives us dinitrobenzene. Okay. Now after treating with H2S.NH3, this gives us selective reduction of nitro group as NH2NO2. Now after treating with NaNO2 and NaNO2 and H2SO4, it gives us the product which looks something like this. This is a Sandmeyer type reaction. HSO4 negative NO2 on hydrolysis. It gives this. Okay. So the P corresponds to here. P corresponds to 3. Now let's see what happens in case of Q. Now this is for P. What happens in case of Q? So here when it is treated with concentrated H2SO4 at 60 degrees Celsius, gives us something like this. OH, OH, SO3H. On treating with NO2 positive, it gives this product OH, OH, SO3H, NO2. And with dilute H2SO4 and heated with dilute H2SO4, it gives the final product as OH, OH, NO2. Okay, so here I guess Q is corresponding to, Q corresponds to here 4. Yeah, Q corresponds to 4. Okay, so P corresponds to 3 and Q corresponds to 4. Okay, so now let's see what is happening in case of R. Okay, so let's see what's happening in case of R. In case of R, we have this. Okay, yeah, in case of R we have this. So with SnHCl, it will undergo reduction. SnHCl, it undergoes reduction and forms an amine. NH2 on reaction with CH3COCl, it gives NHCOCH3 with concentrated H2SO4. It gives us SO3H with an HCOCH3, and with and after treating with HNO3, the product that we will get is like this: an HCOCH3 NO2 SO3H. Okay, and now after treating with dilute H2SO4 and heated dilute H2SO4 and heated, we get the product which looks something like this: NO2 NHCOCH3. And now further treating it with base, it gives the product like this, final product like NH2 NO2. Okay, so here R corresponds to 2. R corresponds to 2 in this case, C6H6 and 2O2. Okay, fine. So now to draw the reaction sequence of S, I need to erase one part, so I am going to erase P here. Okay, so now we are ready to discuss the part. We are ready to discuss part S. Okay, so in case of S, we have the reactant as this. Okay, so let's draw the reactant here, 3 NO2, and now after treating with KMNO4 OH negative, heat, we get the reactant as NO2 COO negative, and now treating with aqueous acid, we get it as NO2 COOH. Now treating with SOCl2, we get the product as COCl NO2. Now final product after treating with ammonia is this CO and H2 NO2. So I guess S corresponds to 1. Yeah, S corresponds to 1. So the correct option here is option P corresponds to 3, Q corresponds to 4, R corresponds to 2, S corresponds to 1. So the correct option here is option C. Okay. So now let's move on to other question. Question says, match each coordination compound in list 1. Match each coordination compound in list 1 with an appropriate pair of characteristics from list 2 and select the correct answer using the code given below the lists. Okay, so here CrNH3 4Cl2 Cl. Here in this case, this is paramagnetic. This is paramagnetic. P is paramagnetic. Okay, and it exhibits cis trans isomerism. Okay, so this is paramagnetic, as here Cr3 plus is paramagnetic in this case, and it exhibits cis trans isomerism. So P corresponds to 3 here. P corresponds to 3. Okay, now Q, that is TiH2O5Cl NO3 whole twice. Okay, so that is Ti plus 3. Here Q is Ti plus 3. It is also paramagnetic. It is also paramagnetic. Paramagnetic, and we can see that it exhibits ionization isomerism. Okay, and it exhibits ionization isomerism. Okay, so therefore Q corresponds to here 1. Okay, now in case of R, PTEN NH3Cl in case of R, here it is diamagnetic. It is diamagnetic because PT plus 2 is diamagnetic, and it also exhibits ionization isomerism, because here NO3 and Cl, they are different, so it also exhibits ionization isomerism. Okay, so here this diamagnetic and exhibits ionization isomerism. So here R corresponds to here 4. Okay, so now S here CO NH3 whole 4 NO3 whole twice NO3, that is CO plus 3. It is also diamagnetic, and it exhibits cis trans isomerism. It also exhibits cis trans isomerism. Okay, so here S corresponds to 2. So the correct option is option B. Okay, so now let's move on to the last question of the question paper. It says that match the orbital overlap figure shown in list 1 with description with the description given in list 2 and select the correct answer using the code given below the list. Okay, so here we can see that here it is D. Both of the orbitals are d orbitals. Okay, so this is also d orbitals, and this is the sigma bonding formula. So therefore P corresponds to 2. D orbitals are there and sigma bond is found. So P corresponds to 2. Okay, so here this is p orbital, this is d orbital, and since parallel overlap is there, therefore this is pd pi bonding. Okay, here this is pd pi bonding. This is pd and the bonding is pi. So this is pd pi bonding. So Q corresponds to 3. So this is pd pi bonding. And now R, since we know that this is p, this is d, and now since bonding is pi, but it is anti-bonding, so therefore this is anti-bonding, and since this is pi, therefore it is pd pi anti-bonding. So R corresponds to 1. Okay, and now in case of S, it is since d orbital is there, dz square is there, this is d orbital, this is also d orbital, and now dd, and since sigma overlap is there, therefore dd, this is sigma but anti-bonding. Okay, so this is sigma anti-bonding. Okay, so the S corresponds to 4. Okay, here, so the correct option here in this case is P corresponding to 2, Q to 3, R to 1, and S to 4. So correct option here is option C. Okay, so this question concludes our discussion on JEE Advanced Paper 2 Chemistry section.